Okay, welcome to class. Happy Wednesday. So today we're going to continue on with linked lists, but I wanted to start off with some announcements, I guess just review of what's going on. Well, first off, I moved the schedule to the top of the syllabus page. I realized I'd always just had it at the beginning or at the end because the first time I ever taught a class, I put it at the end. So it might as well be at the top, and so here it is. So first off, I just want to remind you to take the survey that'll be open through this week, and it's 1 point toward your 100 points in the class, so it could make a difference if you don't take it, so do take that. Additionally, thank you to those who asked questions about Project 3, because you made me realize that I was not totally clear about what you should be timing. And so I added here in the how to time section that I think maybe from the example you could tell, maybe it said that you should add your 5,000 integers into either your array data structure or your linked list data structure. But it wasn't clear that you should also call getN 5,000 times. And the way you should do this is, call it for the 0th slot, the 1st slot, etc., all the way up to 499. So you call it 5,000 times. And then hopefully you will get similar times to what I did when I ran this. But again, do ask questions, because there's always a possibility that there's a mistake or something's unclear in the write-up. Are there any other questions about Project 1 or Lab 7 before we get started today? No? Okay, awesome. So let's jump back to linked lists. So let's see. Today is just more on linked lists. So today's page is just the same from last time. We'll just be working still on our linked list implementation. So to remind ourselves what's going on, let's hop back over to our picture. And can anybody tell me, what's kind of the most basic unit of our linked list that we had to implement as its own class, its own nested class inside? Yeah. Yeah, exactly, nodes. And so what two fields do nodes have?
They had a string.
Yeah.
The content of the node, I think they
Yeah.
something.
Yeah, so we stored the content of the node. In this picture, I'm calling it data, because in general, in a generic linked list, like you work with in the lab, this could be any sort of data. We worked with strings, and we'll continue working with strings. And I think we called that field element, like it is in the book. Because it could be in any type of element in general. And then we also had a link to another node, which we probably called next. But so we kind of had this nested, this almost circular definition. A node contains a node, right? Can anybody tell me what the head and tail are in our linked list implementation? Or what they represent, or what they do for us? Yeah, so the head, what would we say the type of the head is? It's okay if anyone else want to help them out. What's the type of head? Yeah, it's a node. Exactly. It's just the first node in our linked list. And tail is also a node pointing to and it indicates like what node is it? It's the last node in our list. And we didn't actually we made sure that we maintained the tail correctly in the methods that we implemented on Monday, but I don't think we actually really saw why tail was useful, but I think we have, we have this last method, so it's useful to have a tail so that we can get that last node. Cool. We also maintain a size of our linked list. Great. So one thing I wanted to show you before we get back to working on this implementation is you may have noticed that Java has already built in an implementation of linked lists. So if we weren't in this class and you needed to use a linked list for something, you don't have to write your own linked list. You could use Java's. And so we can look at that if we look for like Java documentation. There should be, or maybe Java API. There should also be a link to, maybe that was the right thing. And I like to go to, so this is Java 7. We're using Java 17, so I kind of like to make this Java 17. And we could look for linked list in here, and we would see that it is under java.util, and there's a class called linked list. So let's go take a look at that. And we can see that what we've been implementing is pretty similar to this. We've got elements that are held inside the linked list. And so I guess under the hood, this is actually a doubly linked list, which we'll look at on Friday, where we just have pointers going. We don't just have a next, we also have a previous. But let's see, we can see something like let's look for, here we got methods. We've got, look, the Java, so the Java linked list also has add first, it has add last, it has the method clear. So yeah, you'll notice there is a implementation that Java already has. Any thoughts about why do we bother to write our own linked list class when Java already has one? Sure. Exactly, yeah. So we're writing this because we want to understand how it works. I think also just, you've got to practice writing Java. You've got to practice thinking about data structures. And so a great way to practice is to implement the classic data structures. And we get practice with some patterns in programming, like walking over linked list, etc. So this exists, but unless you're specifically told in your assignments to use the linked list, then you should be implementing your own. But I guess any questions kind of about that? Comments, thoughts? All right. So what if we wanted to, we can see that Java has this linked list class and it's got add first. Where would we go to actually look at this code if we wanted to? Anyone have any ideas? Well, what about, let's say I actually wanted to use this linked list. So we saw, where is this? So it's in java.util.linkedList. So if we wanted to use this, how we would do that is we would say import java.util.linkedList, and then instead of our own linked list, we could actually use this linked list. So that's how you would import it if you wanted to. But another thing I wanted to show is that we can actually look at this code. So I tried to make these fonts bigger, but so if you're in Eclipse, you've got your packages on the left, your project, like my project is CSDI 132. You've got your packages, like we're going to keep working in the day 19 package. But you can also expand this JRE system library. And in here, we have java.base. And we also have, and then inside java.base is where we'd find java.util. Java.util. And under java.util, we can actually just open up the linked list.class. So I'm just going to open that up. And this is where all that code lives that implements the Java implementation of a linked list. And so we can scroll through this, we can take a look at it. A lot of this code is actually really similar to the code that we're writing in class. So I mean, if you really wanted to, you can use this as a reference in your assignments. I mean, it wouldn't really work to kind of copy the whole thing over, but if you want to look at it, you can look at it. Anybody see anything familiar? Like things, another thing, this is like very kind of advanced Java, but we actually know a lot of the things that we can see here. Anybody see anything that we know about? Like what kind of Java stuff is going on here that we've actually learned about? Yeah, we got generics, because we have our angle brackets and a type parameter E. Cool. What about, we also know extends, so we know that it's inheriting from this class. We know implements, it's implementing this interface. What do you think this transient is? Like, not even what it does, but what kind of thing is this? Yeah, modifier, exactly. So similar to, public or static. I actually don't know very much about transient. It's something about, like, if you actually write one of these, if you have a linked list and you want to actually, like, save it, transient, this modifier tells Java, like, not to write it, I think. But yeah, just kind of exciting. I mean, I think this is this is week 8. But we can look at a lot of Java code and kind of know what's going on. So great, and we can look, like, let's look for add first. And well, apparently the code for that is in link first, but here's add first, which we also implemented on Monday. Cool. Any questions about that? Any thoughts? Yeah.
Is this doing like the Java doc comments?
Yeah, and you can see that what is, like, all of this stuff, these are Java comments that are automatically getting turned into this nicely formatted website, actually. Like, we can actually try to line it up. So doubly linked list implementation, let's see where, like that's that, right? Like this is just that text, and I guess everything above that, is just coming from the definition of the linked list. Even, you can see, this is like, code font, right? Like this list is kind of code fonted, and that's because, this is telling it to make it in a code type font, right? So yeah, these are java.comments that generate the nice web page. Cool. Great. So that is that. Let's see. All right, so let's get back to our linked list. And so let's review what we did last time. So we said we made our internal class, our nested class node. It's got this element and it's got a next node. We can also get the element, we can get next, and we can set next. And then in our linked list, we've got a size, we've got a head and a tail. We didn't actually define a constructor, but because when we initialize a linked list, we just want it to be empty, right? So we actually can just use the default constructor that doesn't do anything, and we don't even have to define it. So we won't even need to write anything there. I'm going to say implicitly defined. Oh, I have my funny stuff. Okay. Implicitly defined. We don't need to write it. Great. So we also implemented add first and add last. And then, yeah, and that's all we got to. So as a warm-up for today, I was thinking that we could do the easier methods. So we're gonna save remove first, but let's get some of these easier methods done. So we also have size, first, last, and is empty. So that's wrong. I'm gonna collapse this, collapse that, and here we are. So let's say I want to do size. What type should I return? An int, indeed. Nice, easy one. And what should I return? Just return my size, right? I heard it very quietly in the crowd. Okay, what about, of course I've already forgotten them. First and last, great. Let's do those. Eclipse. What type should I return for first? Yeah. Yeah, so will you say more about that? Sure. Yeah, so if we're thinking about the user of our linked list, they just want, like, for example, let's look at our example. If I call first on this example here, call first, what I should get back is the string MSP, because that is a thing that's being held. That's the first element of my list. You might also think, oh, should my return type be a node? But actually, nope. We want to hide that from the user. We just want to return a string. So it's a string first, and we want to return. Okay, so we heard that we want to call getElement, right? But what do I want to call getElement on? Yeah, and how do I get to the first node? It is head indeed. Great. Okay, so similarly, if I want to do last, same thing. But how do I get directly to my last node? Tail, yeah. Tail.getElement. So here we can already see, or here we can see why maintaining this tail is really useful, because we often do want to get the last element of our list. And if I didn't have a tail, then I would have to walk over my whole list, right? I'd have to start looking at this first element here, and I'd have to call .next or get next a bunch of times. Yeah.
So would you also change the concept to node and just return head or that?
So we could have done something like that, but basically we're thinking of a user of my singly linked list. They don't need to know that under the hood we have this node class. They just want to think of this as a list of airport names, for example, or a list of anything that has an order. And so that's why we're returning head.getElement or tail.getElement. But yeah, it's possible that in some cases it could be useful to return the node. And so, we could have maybe a different method that's like public node get last node, and then we would just implement that as return tail, right? Great. Okay, and then we have one last one, public. So let's do is empty. So I've got public. What should an is empty method return? Yeah, I heard Boolean. Is empty. And so what should I return here? Can anybody tell me? Anyone that hasn't talked yet? How would I know in one line? Yeah. Yeah. So, great. We got our easy ones. Nice little warm up. Let's also, I realized, not being true to my normal form, we haven't even tested this out yet. So let's see, I'm going to make a singly linked list demo.java, and I actually have some code already written for us. And let's grab that. So I'm just copying what's on the page, and I'm going to paste this in, and hopefully don't have any mistakes in here. So it looks like we call add first, but what's happening here? We don't have a toString yet. So let's write toString last because it's a little more difficult. So at least we're not getting any errors as we run this, so that's a good sign. But let's first, before we implement toString, let's implement remove first, I think it is. Yep, remove first is the last one that we need to do. Okay, so let's go back to our picture and think a little bit about what remove first needs to do. Okay, so here's my example input. I call remove first. So can anybody tell me in words what needs to happen? Yeah. Yeah, so head needs to end up pointing to whatever head.next, and I guess actually we called it get next. But yeah, so head needs to move from pointing to whatever it was pointing to being head.getNext. And so what's going to happen to my BZN node? Anybody know? Yeah, it's just going to kind of go away. Anybody have any know what we would say happens? It's not something that we've covered. It would just be if you have experience with other programming languages. Well, we would say that the garbage collector would, like, free that, would take that away for us. So, but regardless, I mean, all we need to do is move head to point to the second node here. And so, let's see. We want to implement this public. Let's say that we want to actually return whatever it was, because a lot of times when you remove something, you also want to return it. And if you didn't want it, you can always just not save that variable, or not save that to a variable. So let's say we want to return whatever it is we remove. We got remove first. So, okay, we already said that we basically just need to do head equals head dot get next. But if I do this, let's say I do this, how am I going to get to my, like, I want to return the first element, right? And if I come back to my picture, so in this example, what string should I be returning? Yeah, I should return bzn. But if I've already executed this, let's say I've already executed this piece of code, is there any way for me to get bzn? Yeah, I think I'm seeing some head shakes, and that is correct. I have gotten rid of my way to get bzn. So, can anybody give me an idea of what can I add on this first line so that I still have access to that, or I have that? Yeah, and what, do you have any, like, what could I write here? Or any other? Yeah, so I want to return, we'll call it, like answer or something. I think this is what the book calls it, so we can call it answer. So answer is what we want to return, and what is my answer that I want to return? I'll even write return answer here, right? So I'm supposed to return, in this case, bzn. So what can I write here so the answer is bzn? So just head? Yeah, head.getElement, exactly. So head.getElement is going to get me, in our case, the string that was stored as the element field in our head node. Okay, so this is looking pretty good. What else do I need to do? Yeah, I got a decrement size. What about if the list had been empty? Well, what should happen if the list was empty? Yeah, I should return null. And I shouldn't decrement size. It should already be 0. I don't need to do any of this business with actually changing my head and all that. And so I can just say return null and, let's see. Oh, yes. Good call. So if what, well, let's use our new method that we have. So if is empty returns true, then we should just return null. And then otherwise, we can proceed with our code, because as soon as we return, we don't execute anything else. So we won't run these lines if we do return null. Okay. Can anybody think of any other? Yeah.
How do we remove what is the last?
Remove last?
Yeah.
Yeah, that's a good question. Well, let's go back to our picture. Do you have any? What do you think we have to do?
Well, I'd actually be very similar as the tail has to be swapped. And
Yeah. So, well, okay, let's think about it. So we're thinking about, we want to remove the last thing. Okay, so let's say, I'm going to put this back. So, remove last. And I'm going to put a question mark. Okay, so yeah, you're thinking, okay, tail needs to go over, like somehow, tail needs to go somewhere else. So where does tail need to go? Then it needs to go to, okay, so it was here, and it needs to go to where? Yeah, it needs to go to MSP. But how do we get there? Sure, yeah.
There are two options for this method. You just do tail out, fill out the previous.
Yeah.
But in this case, we have to cycle through starting ahead until the node we're on its next value, the same level.
Yeah, exactly. So since this is a singly linked list, removing last is going to require us to walk over the entire list, and so that's why we are not implementing it as part of our sort of basic singly linked list. But you certainly could. Like, there's nothing preventing you from implementing it. It's just not efficient, meaning it's not constant time. It takes us the length of the list steps. But yeah, really good question. Cool. So we are removing first, and I'd say we're good for the cases where our list has lots of elements in it, and we're good for the case where our list had no elements in it. But we have one more case that I think is worth looking at, which is when we only have one element in our list. So what have we done so far? We got our answer. We moved head up one. We decremented size. So if I look at my picture, what happened? I moved head up. That's great. I want head to point to null. I decremented my size. That's great, but what's up with tail? What should happen to tail in this case? Is it good? Like, is tail, what happens, like, do I want tail to point to this BZN node? Yeah, tail should point to null. So I just need to add that as a case in my implementation. So let's suppose that after decrementing, size is now 0. So I could do this again, calling my method. If size has gone down to 0, meaning my list is now empty, then I should set tail to null. Let's just double check that I did this. Yep, how I thought I should. Okay. So I guess we're not calling remove first yet, but here we have remove first implemented. Okay. What's our time at? 3:44. Perfect. So the last thing I want to do is write a toString method so that we can actually look at our list. And I think, this is a little bit more complicated than the other things that we've done. So we've got public toString. It needs to return a string. And okay. All right. So let's take a step back and say, in this case, what's our goal what do we want to return? Let's say we want to return BZN, comma, MSP, comma, SEA. So that's our goal for this instance. So the big idea here is that we're going to have to walk over all these nodes to get these strings out, right? So in your Lab 7 like starter code, there's an implementation of this using the string builder class. I usually just do this by starting with an empty string that I'm going to return. What's up? Oh, that's up. Okay. And then in the end, I'm going to return to return. So if there was nothing in my instance, I'll just return this empty string. That seems fine. But now, what should I do? And I think there's this kind of design pattern that you have to get a little bit comfortable with for walking over linked lists, which is, let's think about, so how would I get to, okay, how would I print out BZN in this case? What code would I write to print out BZN? I think we know it pretty well, so someone can just shout it out. Head.getElement, exactly. But what about if we wanted to get MSP? Yeah, go for it. Yeah, I'd have to first hop from head to the next node, which is the MSP node, and then I would have to get element. And so it's not going to be practical to just, do head.get, head.get next.get element, head.get next.get next.get element, etc. So our solution to that is to maintain a current node and update that as we go. So we're going to start with a node. I like to call it current, and it will start out as our head. So current in the first to start out is whatever head is, and then what kind of loop am I going to need to walk over? What was that? Yeah, I can use a while loop. I guess in this case, I didn't even think of this, but you could also probably use a for loop because we have the size field, right? So we could probably write this as a size. But yeah, let's do a while loop. So if my goal in this while loop is to basically use current.getElement, or like append current.getElement to string to return. Like if that's what I'm going to implement in here, then what should my while condition be? And I'm also going to move my current along by calling current equals current.getNext. So these are my, I guess these I've already written. It's not even pseudocode, that's just actual code. But I'm also going to implement this comment here. What should my while condition be? Maybe someone else. Thank you for raising a hand though. Any thoughts? Guesses? Is it what was that? Yeah, so I'm going to go, as long as current is not tail, then I will, so yeah, let's keep going and we can see if we need to make any changes. So how do I append current.getElement to my string? Well, that's easy enough. My string is called toReturn, and I'm going to say use the plus equals toReturn, and I'm adding current.getElement. Yeah, so I do, okay, I want to add a comma. So actually, let's just do that. Yeah, let's do that. And because this is really probably how I would develop it anyway. oh, I need a plus. So great. So I grab the current element and I put a comma afterward, and then I move my current one forward. So let's run this. Okay, so what's going on? So yeah, so first off, tail was a really good idea, but I still have to keep going one more, I want to actually process. So I've got my current pointer, or my current, current is a node, and it's gonna go here, then it'll go there, and then I do actually want current to take the value of tail, right? So I do want current to point there so that I can print my last one. So instead, what other condition then? Maybe, do you have an idea? Yeah, you could. Yeah, well, I guess I hadn't thought of this, but you could do while current is not tail.getNext, right? Like,
okay.
So you could say, if I don't want to go, when do I want to stop? I want to stop, also what time is it? Okay, great. I want to stop, I don't want to execute my while loop when, if I'm pointing at null. So I could do that in two ways. I could do it this way, so this would actually work. That worked. You could also just say while current is not null, right? So both of those would work fine. Then, okay, so we're printing everything. There's one issue, can anybody, sure, what's up?
So don't we actually not want to do that? We want to say while current .getNext when null, otherwise we're going to end up with a comma at the end of the list.
So there are two ways, yeah. So we have you're noticing that, and this is what we were just going to talk about, you've got this comma at the end of your list and you don't like it. So there are two ways that we could deal with this. If we want to do it, if we want to keep, if we want current to take the value of the last node, then we could just delete this comma here and put it in an if statement. So when should we add the comma? I'm going to say to return gets this comma, and in this case, if I want to implement it this way, when should I add the comma? Any ideas? Yeah, so I can say if current is not tail, then that's when I add the comma. So yeah, I mean, this is perfect. This is exactly like when we had current is not equal to tail here. We didn't end up processing our last node. So if we just add this check in here, then we're going to get rid of that comma. And so we've got an implementation that works. But since we have 5 minutes left, let's look at a different way to do it. So we don't want to deal with that. Instead, let's think about another way you could do it. So I'll take this out. What was your thought on how we would do this another way we could do this?
So we stop one student, and then outside of the while append the current .getNext.
Yeah. So if we had, like we had it before, plus our comma. Okay, so so just like before, we're only going up to our tail, but that's perfect because what is current now? So current is, I guess we could do this in two ways, huh? We could so current is our last node, so we could either say, equivalently, we could say to return plus equals current dot get element, Or can anyone tell me another way we could do this? Yeah. What was that? What does that? What's... Are you thinking, like, what string am I getting the substring of? Oh. Yeah, so this is another, yeah, another way that we could do the overall process of, like, getting that comma out of there. I was just thinking that we could also say to return gets to return plus tail dot get element, right? That would also work because tail's also pointing to the end. But yeah, so both of those work. But here we see this sort of design pattern of creating this current node and having the current node walk down our list. And so this might be useful for you in both the lab and the program if you were struggling with that. So cool, that's all for today. Thank you, everybody. Have a good rest of your Wednesday. I can answer questions if you need.